Let us now take the next model from time and distance, where a train running at some speed has to cross a stationary object of negligible length. Let us first understand the equation to be used to solve these type of questions. When a train of length LT running at the speed of ST crosses a stationary object, that is, the speed of the object is 0 as it is stationary, of negligible length, even the length of the object is negligible, so that can be taken as 0 approximately. For example, such objects can be a pole where the length is 0, a pillar or a flag post where again the length is negligible when compared to the length of the train. So for all these three cases, you see that the length of the object is 0. Even in case of a standing person, the length of the person, that is the width of the person, is negligible when compared to the length of the train. And for any single point, the length is again 0. So in all these cases, we find that the objects are stationary and their length is negligible when compared to length of the train. So we can say that the length is 0 for all these objects. Then the equation will be speed of the train equals to length of the train divided by time, where this time t is nothing but the time taken by the train to cross the given object. Again, if we try to compare this equation with the basic one, that is when two trains are running in opposite or same direction. So S1 plus S2 equals to L1 plus L2 by T. We find that it is only a special case of this given equation. Here, as you can see, the speed of the second body is 0. So S2 is 0 and hence it is neglected, and even the length of the second body is 0. So the equation is S1, that is speed of the train, equals to L1, length of the train divided by time. So this is only a special case of the equation that we have discussed in model number 8. Let us now take an example on the model where a train is crossing a stationary object of negligible length. The question here is, a 180-meter long train crosses a man standing on a platform in 20 seconds. Find the speed of the train. So very clearly, the length of the train is 180 meters and the time taken to cross the man is 20 seconds. We are supposed to find out the speed of the train. Friends, before I solve this question, let me explain you one point. Some students generally get confused when the question says man standing on the platform. So the confusion they have is, where is the length of the platform? Remember, the train is crossing a man. It doesn't matter where the man is standing. He may be standing on the platform, or he may be standing on some other train, or he may be sitting inside some other train. In all the cases, the point is that the train is crossing a man but not the platform. So we need not worry about the length of the platform here. Simply we can say that the equation to be used is speed of the train equals to length of the train divided by time. Why? Because the train has to cross its own length as it is crossing a standing man. His speed is 0 and the length of the man is also considered to be 0 when compared to length of the train. So now here the length of the train is given as 180 meters and the time is 20 seconds. So we can say that the speed is 9 meters per second. But as given in the question, the speed of the train has to be calculated in kilometers per hour. So we are supposed to convert the speed in meters per second to kilometers per hour. We know that the speed can be converted to kilometers per hour by multiplying with 18 by 5. So here the answer will be 9 into 18 by 5 kilometers per hour. 9 into 18 is 162 divided by 5, which is equals to 32.4. So the answer here is 32.4 kilometers per hour. Let us now take an interesting example from model 10. The question here is, a train of length 120 meters crosses a pole in 3 seconds. How long will it take to cross a tunnel of length 240 meters? So as given here, the length of the train is 120 meters and it can cross a pole in 3 seconds. Let me remind you, pole here is nothing but a stationary object, speed is 0 and length is also 0. So how long will the same train take to cross a tunnel of length 240 meters? So the tunnel of length 240 meters has to be crossed and we need to find out the time taken by this train to cross it. Now, we know that the equation to be used when the train is crossing a pole is speed of the train equals to length of the train by time. That is for a pole. And for an object like a tunnel, the equation to be used will be speed of the train equals to length of the train plus length of the tunnel or length of the second body divided by the time. Now to find out the time taken to cross the tunnel, we must first know what is the speed of the train, because length of the train is very clearly 120 meters and length of the tunnel is 240 meters. So to find out this variable, we should first find out what is the speed of the train, and that can be done with the help of the first equation here. So by substituting the given values, we can say that speed of the train will be equal to the length of the train is 120 meters and the time taken is 3 seconds to cross a pole. So this gives us the answer as 40 meters per second. So the speed of the train is 40 meters per second. Now by taking this speed of 40 meters per second in equation 2, we can find out the time required to cross the tunnel. So let us now substitute the values. That is 40, which is the speed of the train, equals to length of the train 120 plus length of the body, second body, that is 240 divided by the time. So from this we can say that the time required to cross the tunnel will be 120 plus 240, 360 divided by 40, which is equals to 9, and this should be in seconds because the units here are meters per second. So very clearly the time required to cross the tunnel of length 240 meters will be 9 seconds. So friends, this is the traditional method of solving the problem, where we are using both the equations, finding out the speed of the train from first equation and substituting that in the second equation to find out the required answer. But then if you try to be smart, the same question can be answered without writing all these steps. The idea here is, in both the cases, that is when the train is crossing a pole and when the train is crossing the tunnel, the speed of the train is same, as it is the same train here. And we know that when the speed is constant, we have discussed earlier that when the speed is constant, time is proportional to distance. That is, the time taken in the first case by time taken in the second case should be equal to distance traveled in the first case by distance traveled in the second case, as the speed is constant. So by using these proportionality between time and distance, let us see what we answer. So as given in the question, the first case is nothing but time taken to cross the pole, which is 3 seconds. So 3 divided by the time taken in the second case is to be calculated. So let us take it as T2, which should be equal to the distance to be travelled in the first case is nothing but only the length of the train, which is 120, divided by the distance to be travelled in the second case is the length of the train plus the length of the tunnel. So that is 120 plus 240. So this is equal to 360. So from this we can say that the time taken in the second case should be equal to 3 into this 360 divided by 120, which goes 3 times. So 3 into 3 here is 9 seconds. So as you can see here, the same question has been answered without even finding out the speed of the train. So friends, try to be smart and avoid using these lengthy procedures. You can simply get the answer by taking the proportionality between time and distance.
Likeable. Now, ABLE is the suffer family.
Let us now take the next model from time and distance, which is based on boats and streams.
Vocabulary as
Now, in this particular case, we have a stream or nothing but a flowing river, and in which a boat has to cover a certain distance. Let us understand what are the different cases when it comes to boats and streams. As you can see here, we have a river which is flowing at a certain speed, that is SS. It is nothing but the speed of the stream, or it can also be called as the speed of the current. A stream or current is nothing but flowing water, and whenever the water is flowing, it has some speed which is taken as SS. Let us consider a boat here in this river which has to cover a certain distance. Now here the boat can move in two possible directions. Either it can go against the flow of the stream, which is referred as upstream, or along with the flow of the stream, that is downstream. So upstream is nothing but opposite to the stream, and downstream is nothing but in the same direction of the stream. So let us take what are the various possible cases in case of boats and streams here. Now, as given here, the speed of the stream or the current, or it can also be called as speed of the river, is equal to SS. The speed of the boat in still water is SB. That means when this boat is kept in still water, nothing but a lake, then it can be moving at a speed of SB. So here we can say that the speed of the boat along the stream is nothing but downstream. So speed of the boat along the stream should be taken as SB plus SS. So downstream speed SD is equal to SB plus SS. That is nothing but speed of the boat plus speed of the stream. And the speed of the boat against the stream or upstream. When the boat is going against the stream, it is referred as upstream. So speed of the boat upstream, that is SU, should be taken as SB minus SS. So speed of the boat minus speed of the stream will give the speed upstream. So the two important points here are downstream speed and upstream speed. As you can see here, downstream speed is equal to SB plus SS, that is sum of the speeds of boat and the stream. And upstream speed is the difference here, that is boat speed minus the stream speed. After taking the downstream speed and upstream speed, let us now see how can we find out the speed of the boat and the speed of the stream when SD and SU, that is downstream and upstream speeds, are given to us. So the speed of the boat here can be directly taken as downstream speed plus upstream speed divided by 2. So in some cases, when the downstream and upstream speeds are specified, we can take the speed of the boat as SD plus SU by 2. And similarly, the speed of the stream or the current can be taken as SD minus SU by 2. So speed of the stream is equal to downstream speed minus upstream speed by 2. Remember friends, in some cases, instead of boat, the question is regarding a man who is swimming in the river. So that can again be considered in the same way. Nothing but we need to just replace the speed of the boat with the speed of the man in still water. So equations and all remain same. The only difference is instead of a boat, we have a man who can either swim upstream or he can swim downstream. So whether the question is related to boat which can row upstream or downstream, or a man who can swim upstream or downstream, the equation remains same. Before we take up some examples, let me draw your attention to one very important point here so that there is no confusion while solving the questions. If you observe, when the boat is going upstream, the direction of flow of water and the direction of flow of boat is opposite to each other. Now in the previous cases, we have learned that whenever two bodies are moving in opposite direction, the relative speed should be taken as sum of the speeds. But in this case, when the boat is moving upstream, that is against the flow of water or in the opposite direction of flow of water, we have taken the speed as the difference of the speeds, which is quite opposite to the relative speed case. And similarly, when the boat is going downstream, that is when the direction of flow of water and the direction of boat are same, here we have taken the downstream speed as sum of the speeds. But when we discussed about relative speed, we have learned that whenever two bodies move in the same direction, the relative speed should be taken as difference of the speeds. So friends, don't get confused that why are we taking opposite signs here. Understand this particular case of boats and streams is nowhere related to relative speed. Here, when a boat is moving against the water or along the water, it is not considered as relative speed because there is a physical contact between the boat and the flow of water there. In the previous case of relative speed, there was no physical contact when the two trains were moving in opposite direction or in same direction. So there the relative speed is taken as sum of the speeds in opposite direction and the difference of the speeds in same direction. But here, as you can see, when the boat goes upstream, the water which is coming from the opposite direction tries to pushes the boat backwards. So the boat struggles to move in the forward direction. Hence it takes more time. And when it takes more time, we can understand that the speed of the boat has reduced. So when the boat is going in upstream direction, we take the speed as difference of the speed. Why? Because it is a reduced speed. Similarly, when the boat goes downstream, the water now is coming from behind and it pushes the boat in the forward direction. That is, it is helping the boat move faster. So as the speed has increased, for downstream we take it as sum of the speeds. So let me make it clear, don't compare these two speeds, that is downstream speed and upstream speed, with the concept of relative speed. Let us now take the first example from boats and streams, which is related to a man swimming in the river. Let us look at the question here. A man can swim with the stream at the rate of 3 kilometers per hour and against the stream at the rate of 2 kilometers per hour. How long will it take for him to swim 7.5 kilometers in still water? So as you can see here, a man can swim with the stream. We know that with the stream or along the stream is nothing but downstream. So a man can swim downstream at the speed of 3 kilometers per hour and against the stream is nothing but upstream. So upstream he can swim at the rate of 2 kilometers per hour. So very clearly the downstream speed SD is equals to 3 kilometers per hour and the upstream speed SU equals to 2 kilometers per hour. How long will it take for him to swim 7.5 kilometers in still water? So the distance which he has to swim is 7.5 kilometers, and we need to find out the time required by the man to cover this distance. We know that to find out the time, we should have the distance and the speed. Distance is already specified in the question, that is 7.5 kilometers. Now the only thing which is required is the speed of the man in still water. Now we know that the speed of the man or the speed of the boat, SB, can be calculated as downstream speed plus upstream speed divided by 2. So this can be taken as 3 plus 2 divided by 2, as the downstream speed is 3 kilometers per hour and the upstream speed is 2 kilometers per hour. So 3 plus 2 by 2 is nothing but 5 by 2, which is 2.5 kilometers per hour. So very clearly the speed of the man is equals to 2.5 kilometers per hour. Now the time required by the man to cover this distance can be given as distance by speed of the man. The distance to be covered divided by speed of the man. Distance here is 7.5 kilometers and the speed is 2.5 kilometers per hour. So 7.5 kilometers and 2.5 kilometers per hour. Now 2.5 goes 3 times here. So 3 will be the answer. 3 hours. So the time required for him to swim 7.5 kilometers in still water. That is very important. Understand, he is covering this distance in still water. So that is the reason we need to consider the speed of the man in still water. Right? So that will be 3 hours, because the units are kilometers and kilometers per hour. The time will be in hours. Let us now take another example from boats and streams. The question here is, a man can row 9 kilometers in 3 hours against a stream running at 2 kilometers per hour. How long would he take in rowing the same distance down the stream? So as given in the question, the distance covered by the man is 9 kilometers in 3 hours against a stream. That means he covered this distance upstream and the stream is running at the speed of 2 kilometers per hour. How long would he take in rowing the same distance? So he has to cover the same distance down the stream, and we need to find out the time required to do that. Now we know that when a man or a boat rows upstream, the speed should be taken as speed upstream is nothing but speed of the boat or speed of the man minus the speed of the stream, and this is equal to the distance covered by time taken to cover the distance. We know that the speed of the stream here is 2 kilometers per hour. The distance covered by the man is 9 kilometers in 3 hours. So from this very clearly the speed of the man will be equal to, this is 3 plus 2, that is 5 kilometers per hour. Now once we have got to know the speed of the man, we can find out how long will it take to cover the same distance down the stream. We know that downstream the equation can be taken as speed of the man plus speed of the stream, which is equals to the distance travelled by time taken to cover the distance. So here speed of the man is 5 plus speed of the stream as given here is 2 kilometers per hour. The distance to be covered is 9 kilometers divided by time. So from this the time required will be 9 by 7. It can be taken as 9 by 7 hours. Why? Because the distance is in kilometers and the speeds are in kilometers per hour. So the same distance can be covered by the man when he goes downstream in 9 by 7 hours. So friends, as you can see here, this is how simple is to solve the questions from boats and streams. We simply need to consider the proper equation, that is the upstream or the downstream equation. So as you can see here, the upstream equation is speed of the man minus speed of the stream equals to distance by time, and the downstream equation can be taken as speed of the man plus speed of the stream equals to distance by time. So with the help of these equations, we can just find out the missing variable and get the required answer. So these are the various concepts that are generally asked from time and distance. That's all from this topic. See you in the next session. Thank you.
Now, before we actually look at the solution, let me draw your attention to a very important point here. Without putting pen on paper, the first thing that should strike to you here is option B and option C cannot be the answers. These are all nonsense options. Why? See, the question clearly says that a person travels 285 kilometers in 6 hours. The total distance covered is 285 kilometers. And then some part of the journey by bus, the remaining part by train. We are required to understand how much distance or what part of the distance was covered by train. If your total distance covered is 285, how can the distance covered by train will be 615 or 561? Not possible. It has to be less than 285. So option A and option D are possible, right? 165 and 156 is possible. By any chance, if option D is also a nonsense like B and C, you must be smart enough to mark the answer without having to do the proper solution, right? Just option A would be the correct answer. However, since two options are left, we'll have to do the complete solution, but it is important that you get such points as soon as you read the question. Are you able to follow? There is no method as such to decide. But then, by the time you finish reading the question, you should get some idea about the range of the answer, which is very, very important. And maybe options get eliminated, right? Here 2 have got eliminated. By any chance, if 3 options get eliminated, you are through. You know what the answer is. However, let's look at the solution. And not really a difficult one. I'm sure all of you have found it to be very simple. What does it say? A person travels 285 kilometers in 6 hours. In the first part of the journey, he travels at 40 kilometers per hour by bus, and in the second part, he travels at 55 kilometers per hour by train. The distance travelled by train is. So basically, two different conveyance here. One is by bus, the other is by train. Total distance is what? 285. So we can say distance covered by bus plus distance covered by train is 285, and then time required to travel by train plus time required to travel by bus is equal to 6 hours. Two equations you will be able to solve, right? 6 hours. So one is the distance equation, the other is the time equation. What else do we know? In the first part he travels at 40 kilometers per hour by bus, and in second part he travels at 55 kilometers per hour by train. Okay. So this is one equation. Let's keep it as it is. Distance by bus plus distance by train is 285. Let's work on the second part here, second equation here. What is time? Time is distance by speed. Yes or no? Speed is equal to distance by time. Time is distance by speed. So time taken by train can be taken as distance travelled by train divided by speed of train. What is the speed of train? 55. Plus time taken by bus. What is time taken by bus? The distance travelled by bus, which is dB, divided by the speed of bus. What is the speed of bus? 40 kilometers per hour. This is equal to 6. Now if you observe, we have got two equations with two variables, right? Equation number 1 says dB plus dt is 285. Equation 2 says dt by 55 plus dB by 40 equals 6. Two equations, two variables you can solve. But a better way of solving this question, particularly in this context, would be to go by options. We have only two options left. Check. Check the first one. If that satisfies, that's your answer. Otherwise, fourth option is your answer. Okay? See, one more hint which I would like to give you here is, I would have actually marked 165 as the answer without even doing any of these calculations. Anyway, second and third have got eliminated. The answer should either be option A or option D. I know that option D cannot be the answer without writing any of these equations here. Why? See, the point here is he's asking us to find out the distance that was covered by train. How much distance was travelled by train? What is the speed of the train? 55 kilometers per hour. 55 kilometers per hour. See, the point is, you know that distance is equal to speed into time. Yes or no? The speed of the train is 55 into some time t. The distance travelled by train should be 55 into some time t, which means it should be a multiple of 55. Are you able to follow? The distance travelled by train has to be a multiple of 55. Is 156 a multiple of 55? No. 165? Yes. 55 into 3 is 165. So that looks to be a probable answer. I don't say that it cannot be, the point is not that it should always be a multiple of, it can be any multiple of 155, it can be any multiple of 55, you understand? We are first trying with integer multiples. For example, 55 into 3 is 165. It can be 3.5, let's say the time taken is 3.5 hours, then 55 into 3.5. In that case, maybe it is difficult for you to directly look at the option and decide. But when it is possible, why not? You getting the point? It has to be a multiple of 55, so 165 should be the answer. Anyway, let us substitute and verify. What do we do? See, like I said, either solve these or go by options. Let's substitute the option. What do? We'll assume that option A is the correct answer. Distance travelled by train is 165. If distance travelled by train is 165, what will be the distance travelled by bus? Let's check. Distance travelled by bus plus 165 has to be 285. From this we can say the distance travelled by bus is 120. Now what is the point in calculating the distance travelled by bus? You have to substitute this and option 1 here. If it satisfies this equation, then that's the correct answer. Check. 165 by 55, 3. 120 by 40, 3. 3 plus 3, 6. Satisfied or not? Which means option is the right answer. If this does not satisfy, then you have to go for the next option, which is option D here in this case. So that's how to solve it. I mean, simple question. There was no point. I mean, I don't mean to say that this has not been covered through the video. We have covered this basic concept through video there, but not exactly this kind of an example. So that's about the first one. Let's now look at the second question. What does it say? A boat running upstream takes 528 minutes to cover a distance, while it takes 240 minutes to cover the same distance running downstream. Now the most important part of the question here is that the boat covers the same distance upstream and downstream. In fact, not just for this question, many questions from time and distance are based on the concept where the distance covered is same in the two cases. So what do you do? Just equate the distance in both the cases. What do we do here now? Distance upstream is equal to distance downstream. I'm showing you that regular method there, then we'll see if there's any smart way of getting the answer, right? Distance upstream is equal to distance downstream. Now what is distance? Distance is speed into time. So we can say speed upstream into time upstream is equal to speed downstream into time downstream. Are you able to follow? Distance is speed. What is he asking us to find out? What is the ratio between the speed of the boat and speed of the water? So basically we need to find out the ratio between the speed of the boat and speed of the water current, right? SB is to SW equals to what? Now so far so good. Distance upstream is distance downstream, distance is speed into time, so we're just trying to equate that equation. Now what is given to us in the question? The time taken to travel upstream, 528 minutes, and time taken to travel downstream, 240 minutes. Let us substitute that. We very well know that when a body is moving upstream, when a boat or a man is swimming upstream, what is the net speed? Speed of the boat minus speed of the water current. Yes or no? Speed of the boat minus speed of the water current. And when you're going downstream, the speed gets added up. So speed of the boat plus speed of the water current. So just substitute that. So we can say speed of the boat plus speed of the water current into time upstream, 528 minutes equals to speed downstream. Sorry, this is minus. And downstream is plus, speed of the boat plus speed of the water current into time downstream here is 240. That's it. Simplify and you'll get the answer. In my view, the first two steps are not required. Yes or no? If you have got the question, if you know what the concept is, we'll start with this step. You need not write distance upstream is equal to distance downstream. The examiner will not give you one more mark for doing this. Yes or no? Let's use this. What is important here is how quickly do you get the answer. So just write what is very important, what is very much required to be put on paper. Simplify this and get the answer. So what do we get? See, speed of the boat, 528 into speed of the boat minus 240 into speed of the boat. So how much will that be? 528 minus 240, it will be 288. So we can say 288 into speed of the boat equals to 240 into speed of the water plus 528 into speed of the water. So 240 plus 528. How much will that be? 768. So speed of the water into 768. What we need here is speed of the boat is to speed of the water. So we can say speed of the boat by speed of the water will be 768 upon 288. 768 by 288. Simplify this.
Decrease a
I'm
given
sure
value,
you get
4,800 into 100.
Of course, it cannot be in the 2:1 ratio because if this is 1, 2 will be how much? 288 into 2. Yes or no? 288 into 2 will be in the range of 500, right? It cannot be 768. So 2:1 is ruled out. 3:2 is also ruled out. You know, calculation. The more you practice, the easier it gets. It has to be 8:3. Anyway, when you simplify it further, you get 8:3 as an answer, which is option C. Right? Now, if you understand this question here, only thing that needs to be done is, you know, in one case we are adding the two values of the time, in the other case we are subtracting the two values. What is 768? Sum of the two times. What is 288? The difference of the two times here. So we can say speed of the boat, if you want to, you know, go for a shortcut formula. Not required. Strictly speaking, this one equation is enough for you to get the answer. But if you really look for shortcut formula, what do you say? Speed of the boat by speed of the water. The ratio of these two speeds can be taken as time taken upstream plus time taken downstream divided by time taken upstream minus time taken downstream. Simplify this and get an answer. So maybe it looks easier then in that case, right? 528 plus 240, 528 minus 240. Simplify and get an answer. Option C, 8:3. So walking at 5 kilometers per hour, a student reaches his school from his house 15 minutes early. And walking at 3 kilometers per hour, he is late by 9 minutes. Now if you look at it, there are two different cases. In the first case, he reaches 15 minutes early. In the second case, he is late by 9 minutes. Can you tell me what is the difference in these two times here? 15 minutes early and 9 minutes late. What is the net difference in these two times? Well, you may say it is 6 minutes. But the point is, the difference here is 24 minutes. Now, how can the difference between 15 and 9 be 24? The point here is, if you observe the magnitude you will say 15 minus 9, 6. But if you look at the sign there, right? Sign as such 15 minutes early. Early is on that side, on one side of the axis, and late is on the other side of the axis. So the difference between these two times should be considered as 15 plus 9, 24 minutes. I will explain this to you with the help of a very simple example. Let's say the time at which the school starts is 9 a.m. Right? This student is supposed to reach the school at 9 a.m. What happened? He was walking at 5 kilometers per hour. He reached 15 minutes early. What is 15 minutes early? He reached at 8:45 a.m. He reached at 8:45 a.m. At what speed was he traveling then? 5 kilometers per hour. And in the second case, when he was traveling at 3 kilometers per hour, he reached late by 9 minutes. He was supposed to reach at 9. He reached late by 9 minutes. So at what time did he reach the school? 9 o'clock and 9 minutes. And at what speed was he traveling in this case? 3 kilometers per hour. Right? So in the first case, he was early by 15 minutes. Now he is late by 9 minutes. If you look at the differences here, how much is it? 8:45 to 9:09. The difference is 24 minutes. Right? Now this is what we need to focus on. Are you able to follow? The time difference here is 24 minutes. Or simple. In both the cases, again, the distance traveled is same. Yes or no? Walking at 5 kilometers per hour, the student reaches his school from his house 15 minutes early. And walking at 3 kilometers per hour, he reaches 9 minutes late. So the distance covered is same in both the cases, right? Distance covered in the first case is equal to the distance covered in the second case. Now if we really look at it, how do we get this 24 minutes? There are two different time intervals. Let's say this is T1, right? And this is T2. We know that T2 minus T1 is equal to 24 minutes. This is T2, time 2. It's not the time taken, it is this instant, 9 o'clock and 9 minutes is time 2, let's say. 8:45 is time 1. So T2 minus T1 is equal to 24 minutes. Now what is time? Distance by speed, right? So just substitute. Distance by speed. At what speed was it traveling? 3. Minus, what is this time? Distance by speed. But the distance is same, right? It's not D2 and D1. The distance covered is same in both the cases. So D by 5 equals to 24. But if you observe, the speeds here are given in kilometers per hour, 3 kilometers per hour and 5 kilometers per hour respectively. So time cannot be taken in minutes. Time should be taken in hours. How do you convert minutes to hours? Divide by 60. 24 by 60. Solve for this equation and you get the answer. That's the concept. If you wish to go by the concept, this is it. D by 3 minus D by 5 equals to 24 by 60. Simplify to get D. That's what he's asking, right? The distance between his house and his school. Now what happens here? D is common. So we get 1 by 3 minus 1 by 5 equals to 24 by 60 becomes 2 by 5. Yes or no? 12 into 2 and 12 into 5. Now simplify this, what do we get? So D into 15 is LCM here. 5 times and 3 times. 3 goes 5 times, 5 goes 3 times. So 5 minus 3, 2 equals to 2 by 5. So 2 and 2 gets cancelled. We can say D is equal to 15 by 5, which is 3 kilometers. Option C is the answer there, 3 kilometers. Right? So that's how you do. One simple equation, right? The difference of the two times should be 24. Take distance by speed, 24. If you want a shortcut formula for this one, since this is a very popular example, I would give you a shortcut formula. If you are comfortable, mug it up. Otherwise, the concept is very, very easy, right? Now, what is the shortcut formula? Simple. See, what all values are given in the question? Times are given. 15 minutes, 9 minutes, right? And then the two speeds are given. 5 kilometers per hour and 3 kilometers per hour. Required is distance. Remember, distance will be equal to S1 into S2 divided by S1 difference S2 into T1 difference T2. Now what is S1 and S2? The two speeds, 5 and 3. The difference of the two speeds. What is T1 difference T2? 15 minutes and 9 minutes. Again remember, it's not 15 minus 9. It is 15 plus 9 because early and late, right? So take care of that one. Substitute and see what happens. 5 into 3, 5 minus 3, 2, and this is 24. But you have to divide by 60. Yes or no? Because speeds we are considered in kilometers per hour. Time should be taken in minutes. Or time should be taken in hours. Simplify, what do we get? 2 times, 5 times, 5 and 5 gets cancelled, 2 and 2 gets cancelled, 3 is your answer. So this is how simple it is if you remember the shortcut formula, right? Otherwise, simple concept. So let's now move on to the next one. But like I said, very important, practice a few more questions on the same concept here. Now what do we do? See, understand the question first properly. What does it say? Two cars are moving with two different speeds. along a crossing, right? Towards a crossing along two different roads. So it is something like this. You see, this is like a Y junction. This is car 1 and this is car 2. Both of them are moving towards this crossing, right? Or maybe there's a cross junction, let's say, whatever it is, right? It need not be a Y junction. Now the car 1 comes here and the car 2 is moving in this speed. What is the speed of car 1? V1. What is the speed of car 2? V2. Now what does it say? They are moving towards the crossing of two roads. If the distances from the crossing be 40 meters and 50 meters at an instant of time. So at some point of time, the distances from the crossing, let's say this is C1 and this is, C2. Here is C2. The distance between C1 and crossing is 40 meters and the distance between C2 and crossing is 50 meters at some particular point of time, right? So then they do not collide if their speeds are such that both the cars are moving. They should not collide. They should not collide. When will that happen is the question here. What we'll try and do here is check when will they collide. Let us understand when the two cars would collide, right? When will the cars collide? If they both reach this crossing at the same time. Yes or no? When will the cars collide? If both the cars reach the crossing at the same time. Yes or no? Both of them reach at the same time, they would collide. If they reach at different times, what happens? Car 1 would pass and then followed by car 2. Or car 2 will pass followed by car 1. So what should happen if the cars have to collide? They should reach at the same time. Time taken by car 1 should be equal to time taken by car 2. What is time? Distance by speed. So what is the distance of car 1? 40. By speed of car 1? V1. Yes or no? What is the time to distance of speed of car 2? What is the distance of car 2? 50 meters. 50 meters from the crossing. Speed of car 2? V2. So from this, V1 by V2 will be equal to 40 by 50. 40 by 50 is 4 by 5. See, if the speeds are in the ratio 4:5, then the cars will collide. If the speeds are in this ratio, 4:5 ratio, then the cars will collide. We do not want the cars to collide, such that they do not collide. If they should not collide, their speed should not be in this ratio. So V1 is to V2 should not be 4:5, which is option B here. Are you able to follow? Simple, but maybe a little confusing because here what is not required is to be found. What should not be the ratio is required, right? So if V1 is to V2 is not 4:5, then the cars will not collide. You are able to follow, you are able to get the concept, right? One of the previous SSC CGL exam questions. Since it is different, I thought we would discuss. As is the concept is simple, we are equating time, because only when the time is equal, the two cars will collide. Okay? So time should not be equal. Strictly speaking, the time should not be equal. This should not be equal. This should not be equal. So V1 and V2 should not be in the ratio of 4:5. Then the cars will not collide. Look at this. A, B and C walk 1 kilometer in 5 minutes, 8 minutes and 10 minutes respectively. So basically, the speeds of A, B and C have been given. You know the distance and the time. So distance and time together gives you what? Speed. So I know the speed of A. What is the speed of A? 1 kilometer in 5 minutes. So 1 by 5. Are you able to follow? 1 by 5 kilometers per minute. What is the speed of B? 1 by 8 kilometers per minute. What is the speed of C? 1 by 10 kilometers per minute. It's not in kilometers per hour, but let's not worry about it, right? So basically the speeds are given of A, B and C. And it says C starts walking from a point, from some particular point at a certain time. B starts from the same point 1 minute later and A starts from the same point 2 minutes later than C. So what happens? Each person starts at different times. Then A will meet B and C at what times is the question there. Are you able to follow? So let's say this is the starting point, right? Right, at this point C started, C starts moving. After 1 minute B starts. So B is starting after 1 minute. And after 2 minutes then C. 2 minutes later than C. After 2 minutes A starts. So basically what happens? First C starts, after 1 minute B starts, and after 1 more minute A starts. So basically 1 plus 1, 2 minutes later than C, A starts, right? So the time gap between B and C is 1 minute. The time gap between A and B is also 1 minute. Overall time gap between A and C is 2 minutes. You understand? So just simple. Take this as two different cases. What do we have to find out? Then A meets B and C at what times? We have discussed such questions, but this I'm sure will look to be different, for you guys, because combination of two questions, right? What we have to find out? A crosses B at what time? A crosses C at what time? So basically about crossing there, right? Now, speeds are important. What are the speeds given? 1 kilometers in 5 minutes, 1 kilometers in 8 minutes and 1 kilometer in 10 minutes. See, let's take the first case. C has started. After, we have to find out A meets B and A meets C, right? So C has started after 2 minutes. after 2 minutes A starts, right? C starts and after 2 minutes A starts, right? What is the speed of C? C can cover 1 kilometer in 10 minutes. So I'll say the speed of C is 1 by 10. Forget about the units here, right? I'll tell you why units are not important in this case. Let's take speed of C as 1 by 10, right? Speed is what? Distance by time. Distance 1 kilometer in time 10 minutes. What's the speed of A? 1 kilometer in 5 minutes. So this will become 1 by 5. So we know the speeds of these two persons. Now what happens? See, whenever they meet, C is moving here on the same path, A also moves. Whenever they meet, what happens? The distance covered by both the persons will be same. Are you able to follow? This is like that question which we have covered through the videos. In the videos we have covered a question where it says, a policeman spots a thief and starts chasing him, or a thief spots a policeman and takes to his heels. So what happens? The thief and the policeman initially have some distance between them, but the policeman is running at a faster speed than the thief. So at some point he'll catch him. So at what distance will the policeman catch the thief? Same concept we have to do twice here. Once for A and C, then for A and B. So it's like this, C is the thief, A is the policeman, right? A is running faster, his speed is 1 by 5, C's speed is 1 by 10, right? 1 by 5 is more than 1 by 10, right? So A is running faster, so definitely at some time, after some time, A will catch C. After some distance, A will catch C. Understand, both of them started from the same point, both of them have started from the same point. And whenever A catches C, the distance covered by both A and C are equal. Yes or no? Both of them started from the same point, they have started from this point, C runs, A is chasing C. After some time it will catch. So the distance between the two persons, distance traveled by the two persons is same. So distance traveled by A is equal to distance traveled by C. What is distance? Speed into time. Substitute. What is speed of A? 1 by 5 into time taken by A. Into time taken by A. What is time taken by A? C. What is distance traveled by C? Speed into time. What is speed of C? 1 by 10. Time taken by C, let's say T. C takes T minutes. What is the time taken by A? T minus 2 minutes. Why minus 2 minutes? Because A started 2 minutes later. So if C has run for T minutes, A will run only for T minus 2 minutes, right? A started 2 minutes later. Or you can take it the other way also. Speed of A 1 by 5, time taken by A, T minutes. A has run for T minutes. What will be the time taken by C? T plus 2 minutes. C will run for 2 more minutes. Why? C started 2 minutes before A, right? So anyways, either take T here, T minus 2 there, or T there, and T plus 2 here. Simplify this, get T. That time is the time required for A to meet C. Likewise do it for A and B. You'll get the answer. Now, why are we taking 1 by 5 and 1 by 10? This is not the right way of taking speed, right? Because speed here you see kilometers and minutes. So actually you are supposed to convert minutes to hours. Divide by 60, divide by 60. But the point is, see, you will do some conversion on left hand side at this speed and some conversion on the right hand side on this speed. Both will get cancelled, right? So it doesn't matter. Right? That's the point. So don't waste your time in converting minutes to hours and all that. Anyway, it's going to get cancelled. You will divide 5 by 60, you will divide 10 by 60. Both get cancelled. Simplify this, what happens? This goes 2 times. So what do we get? T is equal to T plus 2 by 2, or 2T equals to T plus 2, which implies T is equal to 2 minutes. That means A will catch C after 2 minutes. A will meet C. A meets C after 2 minutes. So the second time should be 2 minutes. A will meet C. A will meet C after 2 minutes. I think only option here is option D. And likewise do it for A and B also. What happens? Distance traveled by A equals to distance traveled by B. What is the distance of A? Speed into time, right? Distance is equal to speed into time. So 1 by 5 into time taken by A, let's say T, and distance, speed of B. What is the speed of B? 1 by 8 into time taken by B is equal to T plus 1. Why is it T plus 1? Because B will run for 1 more minute. B started 1 minute earlier, right? The time gap between A and B is 1 minute. So B will run for 1 minute. Simplify this. So T by 5 minus T by 8 equals to 1 by 8. Is it visible? Yeah. So T by 5 minus, I know this is looking to be a little complex, but very simple, right? Maybe explanation takes some time, but very, very easy to solve. And because 2 questions have been asked, otherwise one part of it is over. Same part has to be done again. So T by 5 minus T by 8 equals to 1 by 8. So what happens? 40 is the LCM here. 8 minus 5, 3 by 40. This goes 5 times. So 5 by 3, 5 by 3. So we can say this T is equal to 5 by 3. So one time is 2 minutes. Let's say this is T1 and this is T2. As in time taken for A to catch C, time taken for A to catch B. So what are the answers? 2 minutes and 5 by 3 minutes. right? 2 minutes and 5 by 3 minutes. But I think it's not given in the right order. It should be 5 by 3 minutes first and then 2 minutes. But correct answer should be option C here. Right? Anyway, if there are two options, one says 2 minutes and 5 by 3 minutes, the other says 5 by 3 minutes and 2 minutes, then we'll go for the other one. But since there are four different options and only one option has got 5 by 3 minutes, we'll go for it. Right? So time taken by A2 cross C is 2 minutes. Time taken by A2 cross B is 5 by 3 minutes. Very simple. You just refer to the thief and policeman question that we have discussed in the time and distance video. And one last question to close this topic of time and distance. The question says buses start from a bus terminal or a bus stop with a speed of 20 kilometers per hour at intervals of 10 minutes. So every 10 minutes one bus starts. Now what is the speed of a man who is coming from the opposite direction towards the bus terminal if he meets his buses at intervals of 8 minutes? So here the buses are starting after every 8 minutes, after every 10 minutes, intervals of 10 minutes, and the man who is coming in the opposite direction towards the bus terminal meets the buses one after the other at the intervals of 8 minutes. So we need to understand what is the speed of the man from the given data. See, you have understood the question here, right? There is a bus terminal, there is a bus stop which is throwing buses after every 10 minutes, right? Bus comes out after every 10 minutes. And there is a man who is coming in the opposite direction. So he meets buses at intervals of 8 minutes. The buses are going out after every 10 minutes. That person is meeting, the buses at intervals of 8 minutes. And I think Vibhor also has got the answer as 4. So there is a tough competition here. Let's anyway continue and look at the solution. So let's say this is the bus terminal. This is the bus stop, right? The bus terminal there. Okay. Now, buses are coming out at what intervals? Intervals of 10 minutes, right? Every 10 minutes one bus starts. And here is the man, right? The man who is walking. He is crossing buses at the intervals of 8 minutes, right? What is the speed of a man coming from the opposite direction, right? He's coming in the opposite direction and towards the bus terminal. If he meets his buses at the intervals of 8 minutes. Now let's take two buses. Let's understand what happens here. Let's say this is bus 1 and this is bus 2. The man has met bus 1. The man has met bus 1, right? What does the question say? To meet bus 2, it takes 8 minutes, right? He meets the buses at the intervals of 8 minutes. So he is at bus 1 now. To meet bus 2, he will take 8 minutes. After 8 minutes, he will meet bus 2. The bus is moving in this direction, both the buses, and the man is moving in this direction. So this is like a relative speed concept. Two bodies are moving in opposite direction. The man and the bus are moving in opposite direction. Again, what happens? He will meet bus 2. Again, after 8 minutes, bus 3 comes. He will meet bus 3, then bus 4, and so on. So we just take one set of buses and understand this. So he is at bus 1. He is in contact with bus 1 now. After 8 minutes, he is going to touch bus 2. Again, not literally touch there. Don't misunderstand. But he will meet bus 2. So the point here is we need to understand what is the distance between bus 1 and bus 2, or what is the distance between the man when he has met bus 1, they are in the same location now, and bus 2. This distance is important because it's the concept of relative speed. I know the speed of the bus. What is the speed of the bus? 20 kilometers per hour. Let us assume the speed of the man. The speed of the man is m. So m has to be calculated. The speed of the man is m. The speed of the bus is 20. They are moving in opposite direction. What happens when two persons are moving in opposite direction? Relative speed is sum of the speeds. So 20 plus m is the net speed. How much time will they take to travel this distance? 8 minutes. Because he is meeting the bus at intervals of 8 minutes. So I know that the time required here is 8 minutes. So I know the time required. We also know the speed of the man and the speed of the bus. The distance is important. You need to get the distance. How do we get the distance? See, it's simple. The buses are coming at intervals of 10 minutes, every 10 minutes. What is the speed of the bus? 20 kilometers per hour. So it's like this. The distance here will be nothing but the distance required by the bus, the distance travelled by the bus in 10 minutes. The distance between bus 1 and bus 2 is nothing but the distance travelled by a bus in 10 minutes. Because buses are coming at intervals of 10 minutes, right? Every 10 minutes a bus comes. So it's like this. The effective distance between man and any bus is nothing but the distance travelled by the bus in 10 minutes. After 10 minutes another bus comes. After 10 minutes one more bus comes, right? So it's like this. So how much distance will this bus travel? In 10 minutes. Only then the next bus comes. Again next 10 minutes, another bus comes and so on. So distance travelled with the bus in 10 minutes. How do you check that? You know the speed and you know 10 minutes. Can you find out the distance? Yes. Distance is equal to speed into time. What is the speed? 20 kilometers per hour. Time is 10 minutes. But kilometers per hour and minutes is not justified. So convert minutes to hours. So 20 into 10 by 60. So we can say the distance to be travelled is 20 by 6, or for that matter 10 by 3. 10 by 3 kilometers we can say. The distance to travel is 10 by 3. Now if you observe, this is like a relative speed concept. Two persons are moving in opposite directions. The distance between these two persons is 10 by 3. This is 10 by 3. The time taken by these two persons to meet each other. Actually, the man will meet the bus at somewhere in between, right? The time taken by the man to meet the bus is 8 minutes. So you know the time, you know the distance, and you know the relative speed. What should be the relative speed? Sum of the speeds, because the persons are moving in opposite directions. So sum of the speeds means what? Speed of the man, m, plus speed of the bus, 20, equals to distance travelled by time. How much is the distance travelled? 10 by 3 kilometers divided by time, 8. But you know that this is in minutes. Convert this to hours. Simplify and get the value of n. So this is like 20 times 200 by 8, which implies m plus 20 equals to 20 into 10, 200 by 8. What is 200 by 8? 25, right? 200 by 8 is 25. So we can say speed of the man is 25 minus 25, 5 kilometers per hour. 5 kilometers per hour, which is option C.